In this exercise, we're going to practice the use of current division. Now, current division is analogous to the voltage division, or dual to current voltage division that we just looked at. Current division. And we're going to use it to find I3 right here. And you notice that there's a total current, call it I4, which is going to flow and split into two paths, I6 and I3. And so we're going to use current division to find out what portion of I4 is actually going through the 3 ohm resistor, because that's what we're looking for. So first, let's derive the current division. If I have 2 resistors in parallel, and I'm going to use their conduction instead of resistance. Remember, G2 is 1 over R2. Right? And now, what's feeding this is some current source. I'll call it IS. So I have some current IS flowing here. And what I want to know is how much current is actually current I1. Apologize for that, I just got interrupted. Okay, so we're going to try to find I1 as a function of IS. Okay, so what we can do is we can write the voltage that's across this node. We'll call it V. V is equal to R times I. Okay, and it's equal to 1 over G times I. So what we have is V is equal to IS divided by G, the total conductance that is provided by both those resistive paths. And so we get G1 and G2. Remember, when resistors are in parallel, their conductances add. Okay, so we can write this expression for V. Now, the current that flows through the resistance G1 or R1 is simply G1 times V. Or you could write it as V over R1. That's what you're more familiar with. But it's equally G1 times V. But we have V. So let's rewrite that. I1 is equal to IS times G1 over G1 plus G2. And similarly, we can repeat this and show that I2 is equal to G2 over G1 plus G2. Now this is totally analogous or dual to voltage division. Remember, when we did voltage division, the voltage across R1 was equal to the resistance R1 over the total resistance times the driving voltage. Here, the net current through R1 or G1 is equal to the total current that's flowing through all resistors times the conductance, not the resistance, the conductance of G1 divided by the total conductances of all paths. So if you had a third resistor in parallel, you could just add like plus G3 if there was a G3 out here in parallel. Okay, and that's how easy that would be to add. Now, oftentimes, when you only have 2 resistors involved, they'll still write the current division formula in terms of resistances. So we can do that here. Let me write this as 1 over R1 divided by 1 over R1 plus 1 over R2. And if we multiply through the top and bottom by R1 times R2, R1 times R2, we arrive at the formula R2, because the R1s cancel, R1 over R1 plus R2 times IS. This oftentimes confuses students, because if you use the resistance formula, then when you're doing current division, the current through R1 is actually R2 over the sum of the resistances times IS. But when you're doing voltage division, the voltage across R1 is the resistance R1 over the sum of the resistances times the driving voltage. And so students will get confused as to when do I use R1, when do I use R2. I would recommend that you focus on the conductance formula. If you think about conductance when you have parallel paths, then the formulas for voltage division and current division completely follow. Current through R1 or G1 is G1 over total conductances times IS, just like the voltage across R1 is the resistance R1 over the total resistances times Vs, the driving voltage. All right, well, let's put this to use quickly and solve this problem. So what we're going to go after here is we're going to look to find the total voltage across right here. Well, it's called Vx. We already have it here. All right, so let me redraw this. So we have Vx, and we have 6 ohms, and we have 3 ohms, and we want to know what I3 is. Now, we solved in the last problem, we solved for Vx. It was found to be 4 sine of t volts. So all we need to do here is we need to just use the resistance or the current division formula to solve for I3. I3 is going to be equal to, now since we're given resistances here, I'm going to go ahead and use this formula. Okay, but I again recommend that you remember current division by thinking of conductances. So it's conductance of the 3 ohms, which is 1/3 over 1/3 plus 1/6. But we have resistances here, so we'll use the resistances. So it's R2. So this really is like R2. This is R1, if you will. Okay, and this would then be I1 if we're using this formula here, right? So it's R2 over R1 plus R2 times the total current, I4. We got to solve for that yet. Okay. And what is R2? That's 6 over 3 plus 6 times I4, which is 6 over 9, or 2/3 I4. Now we need I4. I4 is going to be simply Vs. Well, we could write it as this. We could solve it several ways. We know what Vx is. It's Vx over the parallel combination of 6 and 3 ohms. So that's 4 sine of t divided by 6 times 3 is 18, divided by 6 plus 3 is 9, so that's 2. So this is 2 sine of t amps, and this is going to go over here. So lastly, finally, we can write the solution. It is 2/3 times 2, so 4/3 sine of t amps. Make sure I have that 4/3 yet. And that's it.